It's a moving truck. It's in a truck that. Yeah, and we'll draw pictures and free body diagrams together here. Yeah, this is a moving truck, a truck that you load stuff into that then moves you across the state. Not the truck is still in the midst of driving. All right. So here I've got. Goodness gracious, I don't even have room to write this thing so big, Tyler. So I've got myself a truck here, right?
You can find that anywhere.
And so I get a basic ramp, something like that. Does everyone get that? Does everyone see the kind of the ramp that we have going on here? I mean, I've got the back of the truck and a ramp going up to it. So there's the moving truck and a ramp going up to it. And you're told the ramp is 5.2 meters long, and you're told the height is 1.5 meters. Now, okay. So already right off the bat, you're thinking, okay, with ramps, I need an angle, right? We don't have an angle. How am I going to get the angle? The finger thing, what specifically? I don't want to use sine.
Inverse sine.
Inverse sine. Oh, yeah, excuse me, sine. I apologize. Inverse sine. Right, sine of theta is opposite 1.5 over hypotenuse, 5.2. That makes sense to everyone? So take the inverse of both sides. That's where we were going here. Theta equals sine inverse of 1.5 over 5.2. Theta equals, give me an angle.
16.76.
16.76.
Wait, can you hold on a second?
Right.
Oh, there is no pressure.
No pressure. Let's do free body diagrams for the piano going up. On the free body diagram, this is on a ramp, so I'm going to want to. Yes, I'm going to want to tilt the axis here, and I struggle drawing tilted axis. I apologize that my axis is a little bit steeper than that ramp, I think. Here's the X, and here's the Y. Here's the piano. Going up the ramp, I've got a force pushing it, right? I got normal force. Normal force, this is the common misconception, does not go straight up. It goes perpendicular to the surface. Okay, so on a ramp, it's going to go purely in the tilted x-axis. Okay, does not go straight up, perpendicular to the surface. On the other hand, gravity does go straight down.
We can just go ahead and break it into one.
Sure, if you can go ahead and jump and break into components, that's fine. Mass of the piano was 1,300 kilograms. So now, next step, break everything into components, right? So I need to draw another tilted XY axis. I'm still going to have FP and normal. Already where they need to be, no need for components. What goes down the ramp? Sine theta. Good. FG sine theta. What goes into the ramp? Good. FG cosine theta. So there's your free body diagrams. There's your free body diagrams. We've already figured out what an angle is. We're going to choose positive and negative, and if you're already working, that's okay. Continue to work, all right? But we need to choose positives and negatives. Let's choose the FP that going up the ramp as my positive. Means down the ramp, negative. Normal force positive. FG cosine theta then would be negative. Let's scroll back up, underline keywords.
Does the
Constant velocity.
problem would require you to work in the x-axis with it?
Not at all.
Okay.
Constant velocity. Constant velocity. Okay? Acceleration is 0. So setting you up here in the x and y axis. And the x, sum of the forces equals ma. You're going to have normal minus fg cosine theta equals ma, but a is 0. In the y, sum of the forces, you're going to have the force of push minus fg sine theta equals ma. Once again, a is 0 even for the y-axis because it's at constant velocity. The y-axis is where the force of push is. That's what you're looking for. And what we just said earlier was, since there's no friction, we don't need to get the normal force from the x-axis here. We're going to be able to get it out. Right, so you should be able to solve now directly to the y-axis for what you're looking for. 1,500 kilogram car coasting up 25 meters per second, going up a hill, angle of 13 degrees. So the idea here is this. I got some hill, and that's probably a little bit bigger than 13 degrees, but oh well, in my drawing. I got a hill 13 degrees, and I can approximate it via ramp. Now, hills, angles do change. Let's approximate it to just a straight ramp. The car is going to go up it, right? Initial velocity of 25, and it's going to make it up to some height. It's going to go some distance up the hill, and the final velocity up here, whenever it makes it to the max height, is 0. That's the idea. And I want to find displacement S up the hill. Now, whenever you're writing this out, you got U25, V0, S question mark. You got to find A because I don't have enough information for you to max. Okay, so now I need to go find A. How can I do that? Newton's second law. Newton's second law. So XY axis here and free body diagrams. So tilt my axis. Normal. Is there any force going up the hill? No, good. There is no force going up the hill. The car is coasting, meaning there is no force driving it upwards. It's going to decelerate. It's going to slow down. This problem confused a few of us whenever we do basic F equals ma, because things could be going forward, positive, and have a negative acceleration. That's the definition of deceleration. Okay? So there is no force going up the hill. What's the only other force that I have happening? All right, since it doesn't say anything, here about friction, let's ignore that. So I only have one other force. Gravity. Gravity's going straight down.
We have a force of push from the car's engine.
Because we're coasting.
It's still running to keep that coasting speed.
The engine runs, but now automatic transmissions.
Put on the throttle.
Automatic transmissions cause it to still go a little bit, granted. But we're going to approximate it to where it's idling. All right, you have it in neutral. A true coast, all right, in neutral, right? Or you turn the car off and it didn't lock up. You're truly coasting 25 meters per second. Or you can think about driving a stick shift, right? You take it out of gear. Okay. So now my two forces, I've got normal Fg sine theta, Fg cosine theta. I'll call up the hill positive, down the hill negative, because that fits with positives and negatives here for what I'm calling these forces, have to fit with what I'm calling positive and negative in kinematics. I said the initial velocity in my kinematics was positive 25. Well, which way is the car going at that point in time? Up the hill, so up must be positive for the rest of the problem. Sum up the forces in each axis. In the x-axis, you're going to have normal minus fg cosine theta equals ma. And what's the acceleration of the x-axis here? 0. The car isn't flying up into outer space or plunging down to the depths of the earth. A is 0. Now, the y-axis is where we're going to really care about. All I have is fg sine theta, negative fg sine theta, to be more precise. Because it's coming back downhill. Just look at your bottom. Okay? Only thing in this y-axis, right here, the only thing in this y-axis is negative force of gravity, sine theta. I'm looking for the acceleration that's in the y-axis. I'm just going to try to solve directly, which is going to work since there is friction. Okay? Force of gravity becomes mg. Sine theta equals ma. Turns out for us, what happens to the masses? They're going to cancel out in this, right? They might not in others, but divide both sides by mass, right? And they cancel out. So I'm going to do that just to go ahead and get you used to that idea. So I'm going to cancel out my masses, leaving me with negative g sine theta is the acceleration. The component of gravity going down the hill is the acceleration of this car. That should kind of make logical sense to you. I mean, it's the acceleration of gravity, so the acceleration of a car that's rolling freely is going to be the component pulling it back down the hill. All right, so now let's just plug up, right? Negative 9.8 sine. What was the angle of this hill again, please? 13. So what's A come out to be? Negative 2.2. Great. This will let me come back up here. Now with this knowledge about A, take a kinematic and solve. Notice that my initial velocity is positive. It's going uphill. The acceleration is negative because it's going downhill. That must be opposites. Take an equation to solve for S. What would you like me to use? Yeah. A squared U squared 2AS. 0 squared equals 25 squared plus 2. A is negative 2.2. S. S is going to come out to be, moving the 25 squared to the other side, negative 25 squared divided by 2 times negative 2.2. What's S come out to be, somebody? $142 meters. Do you want me to work this? Let me work this through step by step. What's 25 squared? 600 and what? 625 plus 2 times negative 2.2. You don't need to calculate for this. Negative 4.4 for S. Move my 625s to the other side, right, and subtract it over. So now I got negative 625 equals negative 4.4S. S is the end goal. That's the displacement. Divide both sides by negative 4.4. and I get a displacement uphill of what? Somebody in? 142. Let's check sig figs and go ahead and wrap it all up. Looks like I get 2 sig figs. So 140 meters.